Good afternoon, everybody. Welcome to last session of the day and how to architect the private cloud. My name's Gareth James. I'm a senior consultant with MCS or Microsoft Consulting Services in Australia. And what I'm going to take you through today is really in three sections. The first one is just to really give you a baseline of what problems are we trying to solve when we talk about cloud and what we mean when we say cloud, and just go through some of the things that make a cloud a cloud. Then secondly, I'm going to go through into some of the architecture paradigms that we used when services designed a private cloud based on the Microsoft System Center stack. And then lastly, I'll be stepping you through a demonstration of what that built system actually looked like or looks like. So this isn't sort of product team or marketing stuff. This is the experience of a services team who actually architected and built a private cloud on the System Center stack. It's a solution that we make available to our customers that we've rolled out through several customers around the world, and it's stuff that we have real-world practical experience in designing and implementing and also running. I'm mindful of the fact that I'm the last thing between you, beer and food. I have no idea how I'm going to be mindful of that, because quite honestly, it's not going to change my content any. So, let's have a look at some of the data challenges that we face in the data center. I don't want to spend too much time on these marketing slides, because I'd be surprised if it isn't the same story that you've all heard before. So, some of the challenges, obviously, server sprawl and certainly the proliferation of virtualization has made that a very real challenge in terms of before we had server sprawl, now we have virtual server sprawl, which in some ways makes your administrative overhead even worse than it was before. Compliance and security are often pretty big obstacles to getting things done, and also where IT budget goes, most of it goes in sustainment as opposed to going into investing in new capability. And also over in the bottom right-hand side there, you can see infrastructure complexity, and the example there is the average billion-dollar company maintains 48 different financial systems and uses 2.7 on average ERP systems. So that really tells you that a lot of organizations have multiple siloed teams. Left hand doesn't necessarily always know what the right hand is doing, and quite often you end up trying to achieve the same goal multiple times. Virtualization, as great as it is not enough. Virtualization alone is not enough. If we have a look there at the graph there, we can see a traditional data center versus a virtualized data center, where you break down, and of course this is on the average. Sometimes it might be more, sometimes it might be less, but on average, we tend to see, of course, lower infrastructure costs from a purely hardware perspective, as you're consolidating and bringing more workloads and getting more out of your tin. Your agility goes up, but then your software costs go up, your labor costs go up, and your management complexity goes up. So overall, you can see the difference between those two graphs is there is a reduction, but a very slight one. So how have we done things traditionally in a virtualized world? And this is really where we're leading us into where, what we see the benefits of cloud are and where our focus is someone requests something. Business unit wants something to facilitate a business goal. A good example is you may have a new line of business application coming online. Your organization that has 2.7 ERP systems now decides they want to have 3.7 ERP systems, and they're going to bring another one online. So they stand up a project to do this. Project goes to the infrastructure teams and says, okay, well, our developers need X amount of servers and a little sandpit environment to start the development process. And it's a fairly typical story for how these types of requests kick off. Goes to IT and starts to the infrastructure teams, and they start provisioning. So they'll provision the virtual machines. Usually, most teams have their sort of at least their operating system deployment automated to a pretty reasonable degree. But the story certainly doesn't end there. So you're starting to provision them. You may have to provision them into some kind of siloed dev environment, as I mentioned before. Then you've got all the good stuff of asset registration and setting up monitoring and making sure all the agents that are on there, and BAU will often have a checkbox of things that have to be met before they say, yes, this meets our standards and we will support it. So even though the provisioning of the actual machine itself in terms of time is usually a trivial thing, the end-to-end process of when the request is made to when a usable service is spat out the other end can sometimes be a longer time. So you can see all of those cycles that it goes through, and anyone who's been an infrastructure admin in this room can relate to what I'm saying, and that the deployment of the OS is just one part of it. I mean, you'll even get to the point in larger organisations that have very siloed delivery teams where even provisioning of the machine itself is a multi-stage process. You go to the storage guys and they'll provision all the LUNs that you need, and then you go to the infrastructure guys and they'll provision the servers, and then you go to the networking guys and they might provision additional VLANs if they're required, and then it'll go to the BAU teams and they'll do all their stuff to it. So it's still crossing multiple silos and multiple teams of expertise, and that's an important thing to note as well. So, and those were just animated through. See how much quicker it is with the cloud approach? So really what this slide is saying, and the moral of this story is that you still need to go through those steps in a lot of way, right? I mean, cloud all of a sudden doesn't mean you magically don't have to provision LUNs anymore. Of course you do. It doesn't mean that you don't need to deploy your agents. Of course you do. It doesn't mean that you don't go through all your checks and balances to make sure the security teams are happy with what's going on. Of course you do. But it's about doing it in a different way, and the way that it's different, firstly, is looking at it at very high degrees of end-to-end automation, where those different teams and those different silos and those different areas of expertise come together to automate a cross-silo process which doesn't have to manually hit steps. We take what they do, we bring it into one process, and we automate it. It's also about slightly different ways of thinking as well, which I'll get into. So, what are the benefits of doing this within a private cloud? Well, this graph, which is actually based on real data, I didn't just sort of go nice colours and just make up the sizes. This is based off industry and IDC and internal data. This is the sort of output that you have, that you can see further reduction in that overall cost. So it's about lowering your system maintenance costs as opposed to them going up. Again, by bringing in high degrees of automation across those silos, the day-to-day tasks that normally take the interaction of different teams, those should be automated to reduce that cost. We're not for a second saying that we're really. I mean, these systems are still complex, and the interplay between them is still complex. But it's really about more automation to try and reduce the day-to-day uptake. That's a bit of a plug from the product team in terms of the licensing costs and how you can consolidate using sort of System Center and Data Center enterprise licensing to reduce that burden. I mean, the main thing there is in terms of application of Data Center from both a System Center and a Windows perspective, applying that to Fabric hosts, which then gives you, unlimited virtualization use rights underneath is a very good thing to leverage to reduce costs. I'm not a licensing guy. I certainly don't speak for the licensing team, and I try and stay as far away from licensing conversations and discussions as I possibly can, so that's the only time you'll hear me mention it. And you really want lower hardware, infrastructure, and facilities costs. Now, this is something at Microsoft that we have a vested interest in getting right. I don't know if there's a couple of small services that we've been running for a little while now. I don't know if you've heard of them, things like Hotmail, Xbox Live, and more recently some of the larger cloud services like Office 365. So we've been doing cloud stuff for a long time, and we've been running very large data centers for a very long time. In fact, I'd really say about the only other organisation in the industry that could claim to have data centres as large as ours and as well run as ours are Google. Google and us have really been leading the way in world-class efficient data centers. So running these things costs money, and money going out is not conducive to a good share price. So we have a vested interest in running these things as efficiently as we possibly can in order so that to keep our overheads down. And this is the experience and the learning that we bring to the table when we bring these private cloud designs to market. And I'll touch on that in a few more details. I've got some interesting anecdotes from some of the guys who run those large internet data centers. So the cloud drivers, obviously, agility. I mean, anyone who's worked in IT for long enough knows it's a common complaint from business that, yeah, IT provide us a good service, but often they're just not fast enough. They can't respond fast enough to the changes that we want to make or the requests that we have, and that's not necessarily the fault of anybody in this room. We're all out there trying to do the best job we can. And sometimes business, when they make requests, obviously are blissfully unaware of some of the technical and engineering challenges that we face in terms of making all this stuff work together. So the easier we can make that, then the more agile we're going to be. So cloud really is about the paradigms that we've seen leveraging from that base of virtualization. So I mean, obviously virtualization is going to give you good density, make the most out of your hardware resources. I mean, there's nothing new there. We're starting to really come into that. I mean, we've been talking about elastic infrastructure, things that can scale up, scale down on demand. We've been talking about it for a lot of years, but the technical reality of being able to do that efficiently and effectively, I think, really is only really now coming to bear. Now, the next part of the cloud paradigm, which is really starting to get into the stuff that really does make it cloud, is self-service. So if you have a repeatable task that you have good automation for, why would you need to ring the help desk or ring IT or contact your admins to have a service provision for you? Why can't I just go to a website and make that request? And then if the capacity is there in the system, the administrator shouldn't need to be involved. It should just auto-approve and go and provision what I'm requesting. And then the next element there is usage-based. So we're hearing about that in cloud, about metering and that utility style. The analogy that everyone loves is the whole electricity pricing thing. You flick your light switch on and you're paying for power, you switch it off and you're not paying for power. So you're paying for what you're consuming. Now, this is a little bit of when we're talking about private cloud, it's nice in theory. When you're talking public cloud, it's absolutely critical. Right? You have to have really solid monitoring, and you really need to know what people are consuming in order to be able to charge them effectively. Because it's a different economic model. It is going to a usage style, and a lot of businesses, when they're looking at public cloud, are saying, why am I in the business of provisioning, why am I running an IT shop if IT isn't my core business? I want to achieve business outcomes. Why can't I just effectively have what I need? Why am I paying for all this infrastructure and admins and all this other stuff when really all I want to do is run an app? So that's what private cloud's about, is giving you just that app, and the burden of all the other stuff somebody else does, and you pay for what you use. Private cloud is completely different, because private cloud is on-premise. It's your kit. It's your gear. It's your admins. So you've still got that capital cost. So it doesn't change the economic model in the same way that public cloud does. But where the usage-based metering certainly comes in handy within internal discussions, especially in organisations where money transfers hands internally between business units, is IT can start to, with these technologies, IT is able to go back to business and say, well, the finance department's consuming 20% of our resources, and legal, they're all paying their, they're consuming 80% or whatever it is. So when it comes time then for the IT budget, you can start to make some business decisions around who should be paying more or less for that. The other thing is we have, again, and this is a slight change in thinking, and it does grow out of that public cloud, is it's the tale of two ways of thinking. So you've got the service consumer. So cloud gives them, and what they're really wanting is they want that on-demand self-service that I talked about. They want utility-style pricing. They want elastic consumption. I don't know how many of you are aware, but in Australia, not too long ago, the government launched a website called My Schools, where every school's performance, performance of every school, of students in every school, was ranked against a national rating system. Now, without going into the psychology of whether or not that's a really good or really bad idea, the website was made available, and for the first week it was down. Basically because everyone jumped on it at the same time, and whoever the service provider the government used couldn't scale to meet demand, and it brought the whole lot down. If they'd have provisioned within a cloud capability like Windows Azure, for example, wouldn't have been a problem. It just would have scaled out for the use, they would have been charged appropriately, and then when the initial interest dries off, it scales back down and they start paying less. The last point is a very, very important one in terms of how we bring these things to bear in real life. Well-defined and consistent quality of service. So this is really how we can take a lot of the load off the admins and how we actually also work these types of agile automated systems within current IT change and release control processes. Then there's a service provider's view, which is I want optimized resource usage. I want all of my tin running as hot as I can bear it. I don't want unused cycles. I want to squeeze the most out of what I've paid for. Standardization and automation, and that goes to the last point from the service consumer's point of view, that's how you provide that consistent service. Classification of service, that's potentially, you've got old gold, silver and bronze. You may have different SLAs attached to different levels of service. You may have different cost rates for different levels of service. And people and process aligned as a single service, and this is what I talk about again when we talk about change and release processes, then working into the technology that we deliver. And everyone's happy. So the cloud attributes, I mean, we know about, I've talked about the things on the top. Private cloud, down the bottom is the important ones, control and customization. Apologies for the American spelling on customized. So it's about how much control you're willing to relinquish for economic efficiency. This is really a trade-off. So when you're consuming public cloud services, they're very standardized. There's a set thing, number of things that you can buy. The prices are set and they're all the same. And if you want, oh, can I have, that, but, I don't want the fries on the side, then sorry, that's not provided. This is what you get. The advantage to that model is it's comparatively very inexpensive to doing something highly customized in-house. When you go private cloud, when you take back that control and have that ability to customize, then obviously the more you customize, that then starts to erode your economic efficiencies away. So it's a balancing act between those. So now to get into the guts of what we've built. When we sat down to architect this thing, there were some paradigms that we kept in mind, and these are the things that really drove all the decisions, architectural decisions we made in terms of how we built this thing. First of all, I just want to clarify what we have actually built. So what I'm showing you now is called Data Center Services, or DCS for short. It is a service offering supplied by Microsoft Services. So I want to make very clear, this is not a Microsoft product. This is a services offering. So it has integration between a suite of Microsoft products, but DCS itself is not a skewed product that you can go and buy from your account manager. It is a service offering that you can go and get from Microsoft Services as a consulting engagement. Now, I'm showing you this for two reasons. One, to let everybody know that the DCS is available, and go and see your friendly services exec if you want to buy it. But the other reason is it's a great example of what can be built on the Microsoft platform. And this is all out-of-box stuff. Right? There's not a lot of secret sauce in here. We've just used the products as they were intended to be used. We've put it together with a reference architecture. No reason why anyone in this room can't go out and build the same thing. So what is the system for? Well, I haven't gone into the different levels of cloud in terms of infrastructure as a service, software as a service, and platform as a service, but this is focused exclusively on infrastructure as a service, or the portion of it that I'm going to show you today is focused on infrastructure as a service. So that is virtual machines is really what it's all about. So I've gone to a portal, I've requested a number of virtual machines, and you get compliant and BAU supported virtual machines spat out the other end. So it's really focusing on that infrastructure domain. So the first thing that we had front of mind when we designed it was we wanted to supply a perception of infinite capacity. Now, it's obviously not possible to supply infinite capacity because nobody has an infinite budget, but we want to give that perception so that when someone goes to make a request, they don't have that experience of, oh yeah, but actually there's no ports left on the switch, so we're going to have to order a new one, and that's going to take 4 weeks. And so we put processes in place to try and avoid that type of scenario happening. We want to give the perception that every time they hit the word pool, they want something, they hit a button, and it's just there. Perception of continuous availability. The service always has to be up from the customer's perception. Now, again, it's perception of continuous availability. We want to provide that. Things fail. It's a fact. You're dealing with electronic things. They fail from time to time. It happens. How do we deal with that is the important thing. And there's actually another bullet point that speaks exclusively to that. Drive predictability, and we do that through very tight coupling of process and technology, and through very high degrees of automation. Taking a service provider's approach to delivering infrastructure. So those points were up on the screen before. This is really about taking, even if you're supplying service to internal business units, the system is set up to treat it like they are externally paying customers who you have SLAs with. That may not be the case, but the system is set up in order for you to do that, and that's the mental approach that we took. This speaks to the perception of continuous availability, resiliency over redundancy mindset. I won't talk about it in detail because I've got a slide on it in a few moments. Minimise human involvement. Again, that comes down to very, very high degrees of automation. In most cases, if the system is running as expected, people are hitting it, they're making requests are being fulfilled. The only time an administrator should be involved is if something goes wrong, or if you're triggering alert warnings for coming to the limit of your capacity, and you've got to think about provisioning more. Optimizing resource usage, and again, that's just a virtualization paradigm in terms of high availability clusters and getting as much use out of those clusters as you can. Incentivize a desired resource consumption behaviour, and this really speaks to point one. If you're going to supply a perception of infinite capacity, that's great, but on the very first slide we talked about some of the problems, and one of the problems is VM server sprawl. So if you're going to provide a perception of infinite capacity and you're trying to avoid VM server sprawl, those two don't necessarily link. So what we've done is we've put in what we call hard mechanisms and soft mechanisms to try and incentivize your consumers to do the right thing. A hard limit is quotas, which we enforce. So we can say, okay, your organisation or your business unit or your project or whatever it is, you've been given a certain quota within the fabric. You can consume up to that quota, and no, if you try and consume over that, you're going to be told, no, you don't have enough quota. You need to go back and ask for more. And the other thing the soft limits are, and I'll show you when we get to the demo, is we show you the implication of your decision before you make it. So it's very much like if you've gone shopping for a car, the car websites, you'll pick the car you want, and then you say, well, no, I want the ABS pack. I don't really want the leather seats that come with it, but anyway, that's how they bundle it. You pick the optional packs that you want, and as you're picking those packs, you can see the price going up on the car as you do that. It's a shopping cart type experience on a shopping webpage. And we provide exactly that. If you don't show an implication or an outcome for choosing a small VM over a VM and people don't know what to do, guess what? They're always going to pick the large VM because it's better to have it and not need it than to need it and not have it. But if you put the price on that page to say, well, this is and even if you're not charging money internally, even if you're just reflecting this is the monthly cost to the organisation to run that resource, then we find most reasonable people think twice about what they're going to do. So to drill into the resiliency over redundancy mindset, because again, I think that this is one of the more interesting aspects. Traditionally, we've had a very redundant, we've focused on redundancy. We've, having two of everything, making sure that there are no single points of failure within your architectures, and trying to say, well, whilst we acknowledge that component failures exist, we'll lose a component, but that's okay because we've got a duplicate of that component over here which can take the load. That's one way of doing it. Very expensive because you're effectively doubling your infrastructure on everything. Much more complicated and much more difficult to manage as well. And out of curiosity, how many people have seen an uber highly redundant cluster with 2 or 3 or 4 of everything go completely belly up and fail anyway? So now the mindset is resiliency over redundancy, and the idea is to have a replication of that service out to spread over your environment with the knowledge that I'm not going to double my infrastructure cost to make sure that a server doesn't fail. I'm going to spread that service across multiple servers so that if a server fails, I don't care because the service has enough resiliency in it to sustain that failure. Now, the guys, global services who run our data centers have taken this to the absolute extreme. When they get what they call a scale unit, which is a grouping of servers that they put into their capacity, they get those delivered in what are effectively modified shipping crates with about, I think, 2,000 to 2,500 servers in them. All of those, they roll it into a data center, which is a Gen 4 or a Gen 5 data center, so basically outdoors, not a big data center building, just what effectively looks like a massive car park. They dump the pod in, plug it into power and network. Processors go through, build all the servers in the container. They're up in the fabric and running. Those things are sealed and they're never opened. To the point where, if they have a power rating of how much wattage coming into the facility is used to actually run compute workload versus how much of it is used for lighting and various other things. Lights out data centers are trying to get as close to a 1-to-1 ratio as possible. It's not possible to get to 1, but they're running at like 0.98, so very close. Even to the point where the servers that are in those pods they don't have hard drive lights, they don't have power lights. What's the point? Pods never open. Why have them? Why have them consuming power when you don't need to? So the moral where I'm getting to with this is when servers fail in those pods, they don't care. They just leave them to rot in the rack. They don't care. Because of the failure rates, we've got very good figures on, and they did a lot of work with Microsoft Research on mean failure rates and the mathematics behind it. So they know what levels of failures they can sustain within a service. They know those failures are going to, on average, those failures are going to occur, and they just let them happen. And then when a pod reaches the end of its service life, they pull it out, chuck a new one in. So it's the maintenance cost on that equipment is not as high as you would think, given that the pods just come in and put into service, never opened, and then just pulled out when they're done. Now that's obviously at extreme scale, right? At one point, that organisation, I think they were doing an upgrade to being an upgrade to Xbox Live, I think at the time, and they were rolling out 10,000 servers a month. Right, we can't dream of that. In the enterprise, even in countries like the US, you don't ever see that kind of scale. So a lot of the techniques and philosophies that they bring down to us, we need to modify for the enterprise, because obviously we don't run at that scale. We don't have, we're never going to get to a one admin per 10,000 servers, right? Because they've got 50,000 servers that do exactly the same thing. But the moral of the story is, do we continue to have these really expensive SLA agreement with hardware manufacturers where they send a guy in a pair of blue overalls come running out every time a red light starts blinking on a server? Or do we do it a different way? Do we say, we have a little bit of extra capacity within the service, we know we can sustain a certain degree of failure, when a red light throws up on the monitoring console, We leave it. We might leave it for, until a trigger occurs, and that trigger might be a certain percentage of failure, or that trigger might be a 3-month or a 6-month maintenance schedule. Then you send the guy with the blue overalls out. But, you know, it's like raising kids. You don't want to go run into their room every time they scream. Only if it's a particular pitch of scream. Then you know to go run it. But you don't go running every time, and that's the point. So let's have a look at some of these concepts. You can tell that's not a marketing slide. So the first concept is a resource pool. And that's simply a logical grouping of like resources. Now, within the DCS reference architecture, more often than not, a resource pool is defined as a Hyper-V cluster. It could be multiple clusters. Really depends what the needs of the organization in the cloud are. And quite often the resource pooling, when we talk about quality of service, this is often where you apply that quality of service to a resource pool. So you might have a production cluster which is back-ended by really, really expensive high-grade storage. You might have a dev test environment that's backed by cheaper iSCSI or something like that. There's an idea of separate resource pools. You might have a gold resource pool and a bronze resource pool. They may have different SLAs associated with them. The next notion is the notion of a scale unit. Now, again, as I said, in the internet data centers, our scale unit, there's 2,500 server shipping containers. For the enterprise, we probably want to go a little bit smaller. For the current release of the DCS architecture, which is based on Windows Server 2008 R2, scale unit's a 16-node cluster. I found that for most customers in Australia, and I pretty much assume that for a lot of customers in New Zealand, even a 16-node cluster is probably a little bit too big. I tend to sort of hover in the range of sort of an 8 to a 10-node cluster. The concept of a scale unit, though, is a very well-defined set of a unit, which, let's say it's a 10-node Hyper-V cluster, right? You know what its capacity is, you know how much it costs, and you know how long it takes you to provision one. So it might take weeks, or it might take a month. It depends on how long when you put that order in with your hardware manufacturer for them to fulfill that order, for you to receive it, rack it, cable it, get it into your data center, and get it operational. How long does that end-to-end process take? Not just from when the guys get it and start to cable it up. When you know you need it and you place the order. That's the time frame you care about. And you work that process into your capacity monitoring. And this is how we provide that perception of infinite capacity, is that as we're consuming resources within the system, we have a trigger point. We know what our consumption rate is. We know what our average consumption is. So you can say, I know that if it takes me 2 months to provision a scale unit, when I'm 2.5 months out from, I'm running out of capacity alert being triggered, that's when you initiate the provisioning of another scale unit. It's all about defined process. Fault domain. This goes to what I was talking about before. Now, I hate the term domain. We used it in the reference architecture because it's what our internet data center guys use. It's what Windows Azure uses when they talk about failure domains and upgrade domains. I hate the term domain because people get confused. It's got nothing to do with Active Directory domains. So, totally separate. I would have preferred to call them zones, but they're called domains, there you have it. So a failure domain is about that resiliency of the system, is saying, okay, where are my single points of failure? It's not about eliminating them, it's acknowledging where they are, and then saying, my single point of failure, that's a failure domain. And if I have an application that's running that I need to be able to survive a failure, you say that app needs to be architected and provisioned across failure domains. A great example of an app that really takes that resiliency model is the Exchange 2010 DAG design, the way they replicate DAGs across, so that things are replicated in more than one point. If you lose a server, you don't care. Upgrade domains. It's about having enough. It's a combination of process and technology, and also having enough capacity in your cluster to sustain, okay, I'm going to have, if you have a 10-node cluster, let's say for sake of argument, I need to know that I can sustain the loss of 10% of that fabric because I know one of my machines is going to be out being upgraded, being patched or having maintenance done or whatever it is. So you look at the combination of upgrade domains and failure domains, and you start to be able to plan for your capacity and your cluster sizing. Resource decay is what I was talking about before, which is just simply something fails, you let it fail, and you wait for a maintenance activity to be triggered, either percentage of failure or on a timed basis. So when we talk about our reference architecture that we designed, obviously bottom layer is your compute network storage and pooling all of those resources. Then the virtualization layer, which, and again, current architecture is based on 2008 R2. I know 2012's out. It's been out for a day. Give us some time. Again, these reference architectures come from the field. These don't come from the product teams. These come from the guys who are out implementing it on customer sites, who are getting real-world experience. So whilst we do have real-world experience through our early adopter programs and our TAP customers, there's obviously a lag from when the new products hit the market versus when we've got enough field experience to bring a really well-matured architecture to bear. So then we talk about our automation layer, which for us is PowerShell and WMI and those types of processes. When we talk about Microsoft technologies and a Microsoft cloud, talk to your infrastructure guys, talk to your engineering teams, look at your staffing skills. If your people don't know PowerShell, they really need to learn it because it's very, very heavily utilized in these systems. Then our management layer comes in, which in our default architecture is operations manager, config manager, data protection manager for backups, and virtual machine manager. When we implement these, we tend to implement them as a greenfields. So I'm building you a new private cloud. Here it is. But there certainly is scope to integrate with existing systems if there. So I mean, quite often, certainly I've seen it a fair bit where data protection manager isn't the preferred backup product of choice. It's Veritas or Semantic or whatever. So then we need our orchestration layer allows us to integrate with those processes. And the orchestration layer is System Center Orchestrator, which was formerly known as Apalis. So just a quick hands up, who has seen or played with Orchestrator or Apalis? Yeah, that's a bit of a difference there between Australia and New Zealand. Australia, Orchestrator is the front of everyone's mind. It's really the hot topic of conversation. I did a session earlier in the day, which was best practice on Orchestrator runbook authoring, and I was pretty shocked at how low the attendance was. And from that show of hands, I think that one of the key takeaways from this session is you need to go and have a look at what Orchestrator does and how it adds value, because in terms of what we've built here, for mine, Hyper-V's great, VMM's great, config manager's great, ops manager's great, but the secret sauce to this solution that makes it really as powerful as it is two things in my mind, and one is Orchestrator. The second one is System Center Service Manager. And when I go into the demo, I'm going to show you how all these things come together and how Service Manager is really the key for a couple of reasons. So again, as you can tell, not a marketing slide. This is our fabric architecture, just to give you an idea of what it looks like. In a nutshell, the idea is that we have a management fabric, which usually is a 2-node Hyper-V cluster, and that's where we host all the VMs that we need to actually drive the solution. So that's all the System Center components, that's SQL, that's all of those management dependencies. And then you have a number of fabrics, clusters, which facilitate your workloads. Okay, and for the next 20 minutes, I'm going to flick over to the demo machine, and we'll actually have a look at what these principles, in actual real life look like. Yep. Yes, absolutely. Yeah, the deck will be made available So that's, again, got to keep in mind that I actually used the runbooks from the DCS solution as examples for when I did my orchestrated runbook authoring best practices presentation. Had a few people come up afterwards and say, "Oh, can we get those runbooks?" Again, I'll be clear on what DCS is. DCS is a solution offering provided by Microsoft Services. So what you're seeing here, I mean, the philosophies that we use to build it is not super secret, right? I mean, I just told you all. But certainly the IP of the DCS solution itself is services. So if you come up and ask me for the runbooks, you're not going to get them. There is a certified DCS partner program. So if you work for a systems integrator and you're interested about becoming about implementing DCS, then there is a path there for you to become a DCS certified partner. And I actually believe there are already 3 in New Zealand. So we actually don't have any in Australia yet, but we're working on it. So this is the customer interface. So with DCS, we went for effectively 2 interfaces. We were talking before about those 2 worlds, service consumer, service provider. In the DCS reference architecture, we have one view for the service consumer, which is actually a custom-authored Silverlight SharePoint Services web portal. And the service provider's view is actually the System Center Service Manager Admin Console. So we'll start with the web portal and have a little bit of a look at what the user experience is like. Now, first thing I'm going to say, bit of a disclaimer here. This is a shared lab that is actually run out of Redmond in Seattle. So I'm remoting in, I'm VPN'd in, remoting into a jump box, which is then remoting into the lab. So the screen refreshes are really bad. And so it's a bit of a perceived performance thing. Unfortunately, with all of System Center, I can run it on my 16 gig laptop, but you really don't want to see me try. It's pretty poor. So I need reasonable tin to run this on, and the reasonable tin's back in Redmond. So this is what this is the homepage. I keep asking them to put a picture of me on there, but they keep saying no. I think they're trying to tell me something. So we're going into our infrastructure management page. Now, DCS was built as a multi-tenanted system. So the first thing to notice is you can see up here, it's telling me who I am. The interface is security context trimmed, so it's the old Coke and Pepsi analogy, right? If you're hosting services for Coke and Pepsi, you don't necessarily want Coke to see Pepsi or Pepsi to see Coke. So when you log on to this, or when you hit this system, you can only see what the system says that you can see, and that's all echoed off. So you can see I've got a view of a very high-level view of the virtual machines that I have running. Now, these are grouped within what we call a user role. Again, not a term I'm particularly fond of. We used to call it services, which I thought made a bit more sense, but we've aligned with the terminology used in VMM. So within the system, we have really 3 levels. We have a tenant, then within a tenant, we have a user role, and then within a user role, we have actual consumers of the system. So from both a ACLs or an access point of view, and also from a quota point of view, we can apply those at the tenant and at the user role level. So if you can carve up those user roles however you like. You can make them, gold, silver, and bronze. You can make them dev, test, production. You can make them project A, project B, project C. Whatever makes sense for your organization. Within a private cloud scenario, you might have tenants as business units, and then potentially user roles as projects. It's however you've done. But you can say, right, user A, user role A, can't see user role B. So let's actually have a look at the provisioning page, because this really is now, again, the res on these projectors is having to go pretty low here, so we're going to have to do a lot of scrolling around the screen, so I apologise for that. So this is what the user sees when they actually go to request a VM. So we pick a domain, and again, these are all trimmed. So if the user you only want the user to have access to one domain, they can only see one. There might be 20 in the system, but they can't see them. Location, which physical, which could equate to a physical data center. The cloud, the cloud that we want them to access, and this term cloud basically equates to resource pools that I was talking about earlier. So you can see in this example, we've sort of given gold, silver, bronze clouds, and in this case, this user within this tenant can only see one type of cloud. How many VMs I want, give it a name. Now we've actually constructed it so that we can either use what we call a static or a dynamic template. And the idea is that a static template is simply you pick a particular operating system and hardware type, and everything's done for you. Now you can see as I did that what's showing over on the right-hand side has changed accordingly. So you can see the effect on quota, and you can see what the financial effect is. You'll also notice that one of those fields has turned red, basically telling me I'm over quota. So even when the rest of the information is supplied, I won't actually be able to provision that virtual machine because it's telling me that I'm over quota. So this is obviously a simple provisioning scenario where you only apply a very standard set of specs, or you can go dynamic. And again, that dynamic static option is tailorable. So you can say, right, these users can only pick static, or I'll give these users the choice. So from here, I can pick the size of my virtual machine, what operating system I want to deploy, and within this system we also, you can't see it in the demo there, but in the, we made Linux a first-class citizen as well, so the system also does zero-touch deployments of various Linux distros. So, and now I've got the ability, you can see what my monthly charge implication is. I can add extra disks if I want to. So you can see that had an effect both on quota and on price. So that's talking to that, trying to incent proper consumer behaviour. Pick a network and a VLAN, and then I hit go. It'll grind away for a second and then come back and say, yep, your request is being provisioned and be ready for you in due course. So then it flicks over and you can see some basic information about your machine, CPU, RAM, disk, and what its current status is, which is provisioning. Now we've authored this using the DDTKH, which is the Dynamic Data Center Toolkit for Hosters. And what that is, it's a mouthful certainly. All it is just a bunch of web wrappers for System Center APIs. So you can make calls into various System Center products and do it from a web page, so from a web service. So while that's provisioning, what I'll do is show you the service provider's interface, which is System Center Service Manager. Now we use Service Manager for two very important reasons. I was talking earlier before about uniting process and technology and people and doing all that sort of thing. Running one of these systems over time requires some pretty solid process. And what we've done everything that we've done with ITIL in mind. There's a lot to this. There's a lot of process and there's a lot of operations that you need to think about running one of these things. If anyone ever tells you that private cloud comes in a box and you click next, finish, and you're done, has never run one. They only sell one, I would suggest. So this is why we do everything through Service Manager. So everything is done, everything is logged, everything is recorded, and everything follows process. So in regards to that, when the consumer went to the web page and said, yep, provision me a virtual machine, that automatically raises a change record in Service Manager. So there we are, following good process. Now, we're not actually delivering it at New Zealand, but at TechEd Australia, and the session will be available online. I actually do a session with one of our operations consultants, one of our ITIL guys, on process in the private cloud, and we demo this system to show that this idea of agile, this idea of, I press a button at one end and I get a VM spat out the other. Well, obviously that's the Wild West, right? I mean, there can't possibly be any change process in that. I mean, how are you equating, how am I going to go to my weekly change control board and sit down for 2 hours for my 2 minutes where I actually say what my change is, a few people wake up and then go, oh, approved. How does that process work within this paradigm? Well, it doesn't, but it's because the change boards as we know them are not the intent of the way that change process is supposed to work. The idea of a change control board is simply relevant people, not every man and his dog under the sun, who has an interest or vested interest in that change, has the information that they need in order to make a decision about that change. Now, we use the notion of a standard change in DCS. Now, standard change is something in the past may have been something like antivirus signature deployments, right? You don't go to the CAB board to deploy your virus signatures every day. It's a standard change. It's done by the standard process, and it happens exactly the same way every time. Same thing for this and provisioning a VM. Because it's so highly automated, in fact, it's completely end-to-end automated. The automation was done by the IT section according to their processes of what needs to happen for a machine to be accepted into production. And because it's completely automated, we know that it's going to follow that same process every time. So even though the consumer, who could be a business unit operator, made that request, we know that it's an IT process which is going to provision it. And as long as there's capacity in the fabric, we want to empower those people to be able to provision those things so that they're not constantly bugging IT every 5 minutes. So, a change has gone into Service Manager, and in this example, that change has been auto-approved by the system because it's a standard change. Now, if your organisation didn't want to do that, they're not comfortable with that, Service Manager is extremely good at process approval workflows. So you can say someone submits the request, it might need to go to their immediate manager for approval, or it might need to go to IT for approval. Whoever clicks the button, it can go to someone for them to look over the request, make sure everything's okay, and then click the button, and then the automation will pick up and continue on from there. Any logic you like can be applied. You can say, okay, I'll let you provision X, but if you want to provision over 5, then it needs to go to a second level of approval. So any way you want to do it. So if I have a look in my VM provisioning view, now you can see here we've actually done a custom Wunderbar. And to use a vernacular, I'm not taking the piss. It is actually called a Wunderbar. Look it up in the doco. We can see all of the provisioning requests that are going, and we'll see if there's any. We should have one in progress, unless it's bombed. There it is. So that was the one I just provisioned, and it's in the system as an approved change record, and we know what its status is. So this is all following very, very solid change control process. Now, the other thing I wanted to show you, because we have about 7 minutes left, is the way that that it sort of orchestrates between various system center products. So as I scroll around, we achieve a lot of what we achieve by a mixture of Service Manager and System Center Orchestrator. Oh, this screen this res is killing me. Oh, seriously? Okay, while I fumble around here. Just amuse yourself. Someone sing a song or something. Okay, I'll just need to drag that over to my screen for a second. Hang on. There you go. Marvel at the wonders of the universe. No, it's taking too long. Hang on. So, what I'll talk about there is the system makes very heavy use of Orchestrator. So, we have a orchestrate a workflow which is sitting there that runs every 5 minutes, that then trawls Service Manager and says, give me all the open requests. We have then a status associated with that request. So when I initially kicked that off, it was status 1, which said, new approved request. Goes into the system, picks it up, puts it through a routing engine that says, okay, you're status 1, off you go, and I'll start deploying. You can see now that that is now sitting at status 202, so it's progressing through the process. When it's finished, it'll then mark it as a completed VM. That VM then gets created as a configuration item in Service Manager. Again, good ITIL, everything should have a CI associated with it, before it then gets surfaced back in the portal for the user to be able to consume. So the user won't see that VM available to them until it's gone through every process that you needed to go through to be a BAU and accepted and supported machine, which then bubbles back up into the system. Another good example of those integrations of process is some of these workflows are reasonably complicated, and quite often these provisioning processes can be complicated. They unite 2 or sometimes even 3 different systems. You know, VMM's being invoked to deploy the template, and then you might hand over to Ops Manager to go and deploy the Ops Manager agent. Then you might hand over to Config Manager to go and deploy additional software. And so there's quite a number of stages that it can go at. One of the big problems with one of these complicated provisioning systems is if something goes wrong, and it does from time to time, how do I effectively know where and when and where to go look? It's a difficult thing. You need people who really know the system very well to be able to take one look at it and go, I know what point that's failed at, and then they go and look. But that's really heavy IP that you people then need to be effective. So what we've done within all the orchestrator workflows is we've done a lot of error trapping. Every task that we say, for example, go and deploy the Ops Manager agent, has a check and a balance in it to say, well, did you deploy successfully? If you didn't, I'll pump you out to an error routine. And the error routine invokes Service Manager. It raises an incident in Service Manager. So if something's gone wrong, if one of the workflows has failed, it'll raise an incident in Service Manager for your ITs to go and have a look at. That incident report will tell you what workflow failed, where, at what point, and pump out a whole bunch of useful information about, why the process failed, server not found, whatever it is. So that's another example of these things coming together to give you a really usable, sustainable, runnable, system that is well run over time. So we can still see that's growing away. The actual process can take a while. It was never going to complete within the time frame that we had available. One of the downsides is because we have so many checks and balances in place, and because it goes through effectively a routing engine that picks the job up every 5 minutes, the actual end-to-end provision time is not as rapid as, say, a config manager task sequence or something like that. You do pay a bit of a price, internal end-to-end deployment time, in order to get such a modular architecture that gives you really, really good flexibility. So in the remaining minute or so, I'll just flick back to the deck. There are sort of all the related sessions relating to this one. My email address is down the bottom. Feel free to contact me by email if you have any questions. I was supposed to scrub that. And just to close up, make sure you fill out your session evaluation, and you can win free stuff. Because who doesn't like winning stuff? So we're pretty much bang on time. I'm happy to hang around if anyone has any questions. Yep. Mm-hmm. I'm not familiar with the solution that you're talking about. Yeah. Well, I mean, we did work quite heavily with a lot of our teams in terms of the philosophies that we use to architect this thing. So, like I said, a lot of the knowledge came down from the global delivery teams who run our data centers, and also that upgrade domain, failure domain, that's straight from Windows Azure. So we were leveraging a lot of our internal IP and a lot of our information in terms of how we built it. We obviously, again, at enterprise scale, there's some things we have to change because we're not provisioning 10,000 servers at a time. But you will see similarities. That's to be expected. Also, when you're looking at private cloud in terms of what you want it to deliver, I wouldn't be surprised if there's a whole bunch of solutions out there that do and act very much in the same way. I mean, you know, you've got a car, it's going to have four wheels and a steering wheel, right? There's only so many ways that you can achieve your objective. Any other questions? Nope. Well, yep. Yep.